Okay, so what we'll do now is we'll actually look at calculating these two questions. So this first one here, second one is here. So let's begin. We're given A is equal to 2, 3, 1, negative 4, and K is equal to 3. So we're going to now say to calculate KA. So what we actually have now is KA is going to be equal to K, which is 3, and A, which is 2, 3, 1, negative 4, as our setup. So we have our matrix here, and we have our K here. So each element needs to be multiplied by what our scalar is. So we start, we'd have 3 times 2. That's our first one. Then we're going to have 3 times 3. So actually, let me start this over in a way that I think many of you will be familiar with. So we have the top left, so we have 3 times 2. The top right, which would be 3 times 3. The bottom left, which is 3 times 1. And the bottom right, which is 3 times negative 4. So working this out here, 3 times 2 will give me 6. 3 times 3, 9. 3 times 1, 3. 3 times negative 4, negative 12. And that's it. Remember, you're just looking to multiply each element by the scalar. Now, this one here is a little bit more challenging. So what we're actually doing in this case is we actually have a fraction. Nothing actually changes here other than we actually have a fraction. So this is going to be equal to, write back our scalar in this case, which is 12, and A, which is 2, negative 3, 4, and 1. So again, our K in this case is a half, and A, of course, is given here. So we put a half multiplying this bracket. This approach is typically what a CXC question can look like. So get more comfortable seeing it like this. Of course, it can be given as a statement as well, and I'll be giving you some examples that are statements also, where you actually have to take out the information and then, of course, work the problem. So what we're having here now is we're going to have, remember again, each element, let me put a line here so we can separate. Each element in A must be multiplied by a half. So we're going to have a half times 2. So that's the first one. That's our top left. Our top right now is a half times negative 3. We now come down to the bottom. We'd have a half times 4. So that's our bottom left. And our bottom right, we'd have a half times 1. So with that being established, what we need to do next, we need to look and see what we could cancel out. So cancel means simplifying. So we have 2 1s, 2, 2 1s, 2. We can't cancel anything there. So 2 1s, 2, 2 2s, 4. So if you don't remember, what we're going to do next is that whatever number we have here now, or these numbers that I'm circling off, we're going to multiply them to the 1. So 1 times 1 is 1, and 1 upon 1. Negative 3 times 1 is negative 3, which is going to be divided by 2. 2 times 1 is 2. Put it over 1. And 1 times 1 is 1 over 2. So of course, we can still actually simplify this even further. We're going to have, we put it right here. We're going to have 1 over 1 is 1. Negative 3 over 2. 2. And we have here a half. And that there is a half A. Now that we finished here, let's come across here. So we have 3b. So 3 being our scalar, and b now, we're going to have negative 1, 5, 7, and 3. So I'm going to just come down. So each element needs to be multiplied by 3. You need to remember that for your scalars. So, scalar multiplication. So we'll have 3 times minus 1. That's our top left. We now go up to our top right, 3 times 5. We now come down to our bottom left, 3 times 7. And now to our bottom right, we'd have 3 times 3. So with that being established, we now just simplify everything. 3 times negative 1, negative 3. 3 times 5, which is going to be our top right, 15. Coming down to our bottom left now, 3 times 7, 21. And then our bottom right, 3 times 3, 9. And that's it. Now, please remember, scalar multiplications, you're just basically multiplying each element in the yes, and that's it. Now, you need to remember something. When multiplying for your scalar multiplication, each element, as we went through with all of our questions, must multiply the scalar that is given. Now remember, scalars can change, so it's not always going to be something constant. You just need to read the question properly or read what's given to you. And of course, you'll be able to answer this very easily. It just requires you to multiply each element in the bracket to the scalar. Look forward for more videos soon.